Good afternoon.
Hello.
Hi guys. We all here. I think we've got there's about 25 people in the class so far, and we're expecting to get about 50 in today's class. We're going to give everyone maybe 2 minutes to join, but we will start shortly. We are recording today's session. I see people are still joining. There's another 5 people in the queue.
Yeah.
That are starting to join. So please just mute yourself, and we will get the show going in about 2 or 3 minutes. I think you'll know the format in it is that we're gonna Jos will do a quick overview on the topic for hybrid systems, just the key concepts. And then we will open it up for questions. You can ask questions on this particular chat, and we can also ask questions on the WhatsApp. We'll check both as well. But yeah, so super excited to see everyone. Thanks for joining. If I may ask that you may please mute yourself when you join. And yep, I think we're quite close. We are 38 or so. Yes, obviously you are popular, yes, because they came back to the class.
That's great.
And
I'm used to it that there will be more on the second day.
bring your friend and come to the class. Cool. Colleagues, we're just waiting for 1 minute more. We have 40 people in today's class. We're expecting around about 50 to 60. We should get to that number. We are recording this session, so Marinda will make it available. So in case you want to share it or listen to it again, we tried to do data to everyone, but not everyone listened to my 11 o'clock deadline. But I think we supported as the most of those that needed access to data. And we will share the slides post the meeting as such. So we're just going to give it 1 more minute. It's 2 minutes past 2. And then we're going to, excuse me, so we're going to start with the actual session. We are recording it just to let everyone else know. Let's see. Ooh. Excellent. Okay, hi Samantha. System B says yeah.
Hi, Kash. Hi, everyone.
Cool. I see Martin is also here in the class. So for Martin, this is like a voluntary attendance. Nice to see you, Martin. Cool. I can't see any of our colleagues from Zimele. Okay. So you got your hand up. You want to say something? Or is it down? Hi, Comfort. How are you? And cool. Colleagues, we're close to 50. We've got about 45 or so in in this meeting. We're about to start, and just welcome to session, it's actually session 3, but lesson 2 on hybrid systems. Colleagues, just to give you a little bit heads up, in the next week or so, we're going to get you to just sign a agreement to say that you've been part of this masterclass. We are just waiting for Anglo Zimele to confirm those that are existing suppliers, fall under supplier development. Those are the enterprise development. I also want to give you a quick heads up. On the first session, we met with, we explained to you how PUM, the retired expert or the senior expert program works, where Jos is from and Martin is from. And we had 3 reach outs from individual class members that they wanted one-on-one coaching. We actually applied for one already on the system. So that's available to all of the 60 or so in the classes. So remember, as you go into this journey, if you want to able to access PUM individually for your businesses, then you can just drop me an email. We'll set up a quick chat and we'll see if you qualify to get assistance on your own. So colleagues, just be aware, in the next week, we're just waiting for Anglo Zimele to categorize you as enterprise development or supplier development. And then we're going to be able to send you off those agreements. We need you to send it as quickly as possible, because that will allow us to continue with the virtual classes, practical training as such. So colleagues, we're about to start. We have, I think, the 50 or so people in the class. So today is a very, very important lesson. We talked to some very, very key topics of grid connected, standalone. We talk about net metering. So net metering is not easily available in our country. It is illegal, as I've explained, or many of you all have asked me. There's only 1 or 2 cities like Cape Town and eThekwini or Durban that is starting to roll it out. But the reason why we bring in this conversation in is because in months and years to come, that ability to sell back to the grid is very, very important, because it's going to happen. And as our municipalities start to become more capacitated in rolling it out, net metering as a concept is going to be important. It's not that we're trying to take a concept from Europe and trying to explain it to you. So net metering, flowing one way and flowing the reverse way, on the meter, is an important concept. And going forward in months and years to come, if you're an installer, you're going to be having those kind of conversation. I think in today's conversation is also, we have the concept of maximum power, MPP. You're going to see it coming out. I think it's an important concept, together with islanding into it as well. So it's quite a full concept. Melinda, you can help me mute, please. There's a quite full concept of concepts. We did share the slides. We did share the handout. I'm assuming you had an opportunity to read it. You can ask questions on this chat. Maybe post your questions. You're also welcome to post the questions on the WhatsApp chat. We've got open as well, and we're going to be able to. I see there's one person pending. Kent, are you in the meeting? Kent, are you in the meeting? I see the message that you're struggling, but you should be in this meeting. Are you here, Kent? Oh, you're here. Fantastic. You've been let in. I can see you said you're struggling. Okay, cool. Excellent. Colleagues, we're all in this classroom. Yes, we are all in your capable hands. So maybe if you can take us for the next 20 minutes or so, or 30 minutes, through some of the most key important areas. And then colleagues, as you requested, let's go through the refresher of the handout, and then we can go into the questions and answers. Cool. Over to you, Jos.
Thank you, Akash. Good afternoon, everyone. I presume the same people are in the classroom as last week, so I don't need to introduce myself extensively. My name is Jos Slangen. For nearly 30 or 37 years in solar in various companies. and working for PUM now, amongst others, as an expert on solar energy. And well, I will recap the information that you got on this grid connected and other kinds of inverters and system concepts. And actually, one chapter is not in this, was not in this handout, or was not in the information that you got. And that is specifically on hybrid inverters. And thanks to Martijn, we have an updated lecture on this. So I will go in that in a little bit more detail because it is a little new for you. So I'm trying to share my screen. This one. Is this working?
Fantastic. Yeah, I just put it on the presentation mode.
Yeah, I do. Yeah,
Fantastic.
now I have it.
100%.
Yeah. So so what's coming in this lecture? This is the information you got already on this different kind of systems. Grid Connect is what I will explain is actually not so much on the market in South Africa. That is also what Akash said in his opening comments. But in the near future, we hope that this will also be the case. But in South Africa, we have mostly the hybrid systems, which I will go into more detail soon. So this is the general setup, and it can be for. This is the total general of grid with solar panels, inverter, battery, and then some appliances. On grid, you have solar panels, inverters, and directly to the house. And from the house or from the appliances, you go to the grid. And in a hybrid system, which is basically what we will also go into detail, you have solar panel, you charge a battery bank, and via an inverter, you can go either to the grid or to the loads. So the battery bank is included here. So then some examples of nice nice systems, nice examples. This roof is a typical German roof. Why is this a typical German roof? Because there are flowers at the window, and this is you can only see that in Germany, not in Holland. In Holland, the roofs are smaller, but this is let's say a capacity up to 10 kilowatt, about 30 to 40 modules, and a small inverter, and this is typically for net metering. Then when we go to the larger systems, C&I market, you see here the building with a flat roof with solar on top. Typically capacities up to 1 megawatt or even more in large, very large halls. There was always agreement with the network provider for this connection. This is not just doing something. And financing in this kind of systems is the owner of the building and sometimes also a bank. And then the big systems which you can see, and this is, I think this is even a picture in South Africa, where some, I think already more than 10 years ago, some large systems have been built and are still going on. I was in my time at Siemens involved in one of the designs of one of these larger parks. So typically capacities can be over megawatt, over 1,000 megawatt, even over a gigawatt. There is no limitation. The only limitation is the availability of land and the availability of the network, and of course also the availability of the budget. Financing is always investment companies and banks, and these are large utility companies who develop and build and operate this. So going back to this small grid-tied systems, a very simple drawing. Solar panels on the roof. You see the inverter here, and then this goes to the grid. In this case, you can consider the solar system in parallel to the appliances of the house loads. So the solar panels power the house load and can also go in and out of the grid when this is allowed. In a very simple scheme, the solar panels to the inverter, distribution panel, in and out of the grid and powering the loads. Actually, solar is a very simple setup. Once again, this 100% self-consumption in this case. You have solar panels of a certain size, solar inverter, and the home consumes all the energy. And in this case, it says no measuring of the energy meter because you consume all the energy directly. This is only a moment in time. But then when you have some clouds before the sun, of course, and your consumption stays the same, then you need something from the grid. In this specific case, you produce 2000 watts. You consume 4000 watts. This energy is going directly into the home appliances. And you take in this specific moment, you take 2000 watts, 2 kilowatts from the grid. Then in case you have only a grid supply in the night, you consume in your house still some energy and you take it all from the grid. And the energy meter, of course, counts up. And in this case, you produce 4000, you consume 2000. So you divide the energy to the house from the house and the grid. And the energy meter counts down. Or let's say there is a second measurement or second meter that counts up. In this case, you have a very old meter, but modern meters have different countings, and you count for delivery and for supply of the grid separately, so that you can always see what has been consumed and what has been delivered, because in some cases, but especially in the future, there are different tariffs for consuming and supplying. Then this is an overview of the total energy landscape, what can be done. And you see that the whole grid in a country, if it is in Europe or if it is in Africa, can be built up of a lot of things. The conventional power plant, with or without storage. And you can have a hydropower plant, which is a dam in a river or a lake. And this can also supply energy to the grid. You can supply it by wind, by photovoltaics, via batteries or not. It can be consumed in a house. Can be consumed in a car, industrial loads. So yeah, there is someone. Can you put yourself on mute, please? Thank you. So in the total grid, there can be a lot of energy flows coming from a lot of sides and a lot of different types of energy consumption, different types of energy production. And this needs, of course, a lot of control. And this is done by the network operator. In the case of South Africa, this is Eskom, one company. But when you look to the most European countries, you have more companies, more network operators that have to work together. And you have a lot of energy companies who are selling, so commercial energy companies who are selling and buying this energy or trading energy. In South Africa, this is all combined in a state-owned, one state-owned company, which is Eskom. But you see in other markets that can be a lot of companies. So there is a real market in this trading of energy moving. So connection to the local grid, I will skip this. I can come to specific questions when necessary. This feed-in tariff and net metering is also for not for South Africa at the moment. So going to these large systems, I said already, that can be either on the building or on the ground, and there you most of the time you sell energy to the network. This larger system is you can have this full roofs completely loaded with solar panels. This is an architecture, a project on itself to do this in the right way. Of course, the building should be suitable for this. There's always a thing, an argument. Is the roof able to carry the load of the solar panels? And you need always this connection issues. This is the diagram which speaks for itself. I can go into more detail when necessary. Then the solar grid inverters. We need a few minutes to go through this because you have this several types of inverters that are available on the market. Basically, the commonly used one-phase string inverters, which are the oldest in terms of technology. Then you have the micro inverters, which basically is an inverter of about 300 or 600 watt, which can handle 1 or 2 solar panels, and which is mounted really on the back of the panel. So there is a cable coming from the solar panel which already has AC in itself. So this is a product from some US companies, but also produced in Europe for special markets, but only consumer markets. Then we have the larger inverters on a house or on a building, the 3-phase string inverters, which can be a lot of them can be connected in parallel to increase the power when your roof is larger. And you have a special type of inverters with optimizers. And an optimizer is a small DC-DC converter mounted on every panel. And in this case, you can optimize your panels in case you have partial shading. So that when you have a tree in front of your building or a chimney or whatever, then this makes sense to have inverters with optimizers. And then for the very large systems, either on very large buildings or on the ground, you have the high power central inverters, which come often in solutions that where you have 20 feet of even 40 feet containers that can be transported to the site as a complete unit, which contains then the inverter and the DC cabling or connection things, and then also on the AC side, even a transformer to the medium voltage and a medium voltage cabinet. So all this can be combined in this central power station. So this about the several, let's say, types of inverters, all for direct grid connection. So to summarize a little bit, the inverter is designed to synchronize the voltage waveform and frequency with the local grid. That is very important to understand and to ensure a correct direction of the energy flow. So which means the inverter is working directly and automatically towards the grid and is synchronized always. And that brings me to the effect of islanding. When the local grid is down in a blackout, or when someone is switching it off because of maintenance, that also means that your inverter and your solar panels are switched off as well. This is done because it can be dangerous to utility workers who are not aware that there is a solar system connected, and that is done by international norms and standards that from the beginning it was agreed upon that this should be the most important design criteria for an inverter to prevent islanding, so to keep up the network on itself. Then this technology is going into very much detail. I will skip that for now. Important to know that also the inverter is always looking for the maximum power point. We said something about it in the first lecture. So always looking for the maximum power out of a solar panel that is automatically incorporated in all the inverters. And this again shows this, and this from the electronic side of view, how an inverter is basically working. And this leads really to too much detail. Okay, maximum power point tracking again. Then putting modules in the string. So when you connect modules in series, always do that in a way that one set of panels in a series, which is called a string, they have the same orientation and the same tilt angle when it is placed in one string. When not, the one is depicting the performance of the others, so then you lose potential energy. You can solve that with these power optimizers, but in a normal case, try to avoid. When you have this example, you see that you have three orientations: this one, and this one. And this is going to the north. This is east and west. And you should actually use an inverter with three different MPPTs, and they are available on the market. In this case, you have only two, but connect these two fields of solar panels to different inputs on the inverter, or use a different inverter to that, so that you have always an optimized energy production. And these string inverters, you have one string, basically DC, and then the inverter going to AC. And when you have a larger roof, you just put them in parallel and mount them nicely on the roof. This is these optimizers. When you have different orientations, or when you have shading on your roof, then you can make use of this optimizers, which is basically a DC to DC inverter. And in that case, this device takes care that in the end, this string of panels or this panel is not influencing this panel when they work together. That is the background of these optimizers. But then you should always also consider that you have always electronics on the roof close to the panel, which can be also a disadvantage when you have a lot of bad weather and a lot of things from lightning. Then the lifetime expectancy of a DC-DC converter can be lower. And you have some higher cost and higher installation costs as well. And in some cases, then you have higher output. Then these microinverters, a larger device which is mounted behind the panel, same idea as to have electronics in the field, but in this case you go from DC to AC on a panel level. So you connect your cabling, your long cable on the roof is an AC cable, so you don't have an inverter in the house anymore. So you go with your AC cabling, which is a common technique for a lot of installing people. You go to the grid network and to the house immediately. And then this high power inverters, you see a picture again, how it is set up in a large field. This is basically the inverter. And you have a transformer and a medium voltage switch gear in the back. And this is the way this is done. This is typically a power of more than 1 megawatt. And I think in this case, it's even 2.5 or even 5 megawatt per unit. So you have, when you see large fields from above, when you look to Google Maps and look to these larger fields, then you see in every, let's say, every acre or every few acres, you see such a device in this field. Okay. Then I would like to move to this other field. Let me check this one. When I wait. Now I have to. Yeah. Have to go for this one. Then like this, and then like this. This is clear now. Akash, can you confirm that you see hybrid inverter now in the field? Okay. Good.
Yes, I can see it.
Yeah, then we go to this hybrid inverter, which is new for you, which was not in the handout, but we made this recently in PUM to also to be compliant to the let's say the market situation that we have in especially in the countries like South Africa. So a hybrid inverter with a backup and which having a pre-wired enclosure with a solar charge controller, an inverter charger bidirectional, so AC to DC and back, a switch for on the AC side to connect to the grid and to the house. And oh, wait a minute, I have to go back. It's going up. So in this case, you have some advantages of having all separate components. And you have fewer. You have all in one cabinet, which is a very much ease of installation, of course, and lower cost. And you can program, you can prioritize energy flows. That is a very important thing. You can. There is someone. Can you go on mute, please?
Apologies, I'm going to try to look for it. Marinda, help, please. Okay, go for it.
Okay. Of course, you have some disadvantages. When you have advantages, you have also disadvantages. Yeah, you can, in this case, not connect any DC loads. You have some standby consumption because of this prioritization. It's all monitoring constantly. And fixed configurations, which is maybe not the disadvantages, and difficult to repair. It is basically, this is a black box that when it fails, it should be replaced completely. But going into the internal architecture of such a device, basically it's simple. It's a combination of a solar charge controller, an inverter, and a connection to the grid. So going from the left side, starting with the solar panels, the DC input. There it goes on over an MPPT, so it optimizes the output of the solar panel. It goes to it's connected all on DC. Via this DC bus, it's charging via a converter, the DC battery, on a 12 volt or 48 volt or 60 volt, whatever is operational. And then often this DC bus is a somewhat higher DC voltage, a few hundred DC volts DC. because you can make longer distance here with your cabling. And then from this DC bus, you go from DC to AC, also bidirectional. You can also go the other way around. You go to the grid and to the building, to the AC appliances. And of course, with switches, most of the time automatic switches, you can choose between the different energy flows and you can prioritize them. Sorry. So the typical setup, you have seen this picture without the battery, solar panels to the inverters, to the grid, to the home, and in and out of the battery. So during the daytime, when there is solar, you charge the battery. And during nighttime, you can also charge the battery. Of course, also discharge, but depending on the price of energy, on the availability of energy, and of course, on what is used in the house or in the building. When you have, and this is common in South Africa, when you have a blackout, so when you have maybe not a grid failure, but when the grid is switched off by Eskom because it is planned to switch off, then you have your battery, which should be charged at that moment, and you can charge your home. And in case there is during the day, the battery is also charged and the home is charged by the solar panels. So the grid in this case is off. And when the grid is completely off for longer time, then of course you have to design the system in such a way that your building, that your appliances can run on the combination of solar panels and batteries. That should be enough to cover the energy need of the house. So that is again a matter of designing. When you want to be in a situation that you have a longer time availability of energy for your home, you should take care that your energy use is limited here, that your battery is large enough, and that your panels are large enough. When that is not the case, and you can also have the grid available every day, only when it is only for 1 or 2 hours, fine. In that case, you can charge your battery with a typically high current. And this is what all this in this machine, in this apparatus can be arranged, can be programmed, and can be prioritized. So some examples this of an installation. This is a simple one in the house. You see here this inverter, a 5 kilowatt-hour lithium battery, and a switch box. And this is a system in this example where there is no solar. Yeah, that can also be. And an off-grid system, in this case with lead-acid batteries. But you can imagine that you can make all kinds of different setups with a hybrid system. And hybrid in this case means the grid and the battery can work together with the solar and with the energy needs in the house. And this can be programmed by in most cases an EMS, an energy management system, which is available on the market, which comes available in the future, in the near future. It is still in a lot of cases under development, but you see now a lot of examples where this energy management system is doing a good job in prioritizing these energy flows. I think, guys, that we should go to the Q&A session at the moment and see where your questions are. What can I explain once again, or what can I explain in more detail? Can we open this?
Yeah. Okay.
This session
Fantastic.
For Q&A.
Yeah. Yeah, no, that's perfect. Well done. You did it in exactly 29 minutes.
Oh, no, that is nice.
No, within the time. Thank you. Yeah. So that was quite a nice summary. I've got one question. So why would you put an inverter on the roof as opposed to inside the house? What's the pros and cons of it, Jos? And I'm an accountant, so you have to explain to me in layman's terms.
Yes. In case of a normal house, you don't put an inverter on the roof. In case of a large building, you can put inverters on the roof, and it is often done in where you have a large roof of large office, no, not office buildings, but large industrial buildings. There you see most of the time that the inverter is placed on the roof, and there is a legal thing for that, to keep the complete installation on the outside of the building. And often this energy flow is also going directly to the grid, and the owner of the building can take energy from the system, but it is measured in such a way that the owner of the system on the roof is often a different owner than the tenant in the building. And then you still have also the building owner, and this is what you see in European countries, where you can place inverters on the roof. But in all the cases, I didn't show this example, by the way, or did I? So I'm a little bit surprised about this question, but anyhow, the reason is to keep the inverter also close to the solar panels. Sometimes you put the inverter in the house, in the building anyhow, but it is always good to keep the DC lines as short as possible to avoid energy loss over the DC cables.
Okay, fantastic, cool. Colleagues,
And energy loss means also loss of money. Then it comes to you as an accountant.
Yeah. I love how you turned it back as an accountant. Colleagues, any questions? No question is a stupid question. We also made everyone aware that we've got like different types of individuals, some in advanced, some in medium, in this particular question. So I'm going to ask you to post your questions on the chat. Any questions you have around some of the key concepts around grid tied, standalone, net metering, islanding, MPP or MPPT into it as well. So let's just start asking the questions. You're welcome to put the question in the chat in the WhatsApp, or put the chat that's in this meeting, or you're welcome to put your hand up and ask your question. So let's ask the colleagues, for those of you that want to ask any questions. Marinda, please help me to see hands up, because I've got 5 screens open here, and I just want to see any questions, colleagues. Maybe put your hands up.
No,
I can see. Okay, Latani, if you want to go ask your questions, just unmute, please, and then mute when you're done. Go for it, Latani.
Okay, good afternoon, Kishi and the team. I just want to ask Jos on the hybrid, the inverter, because we do have a normally inverter, which is very compatible and usable. Now, you mentioned that hybrid inverter does have some disadvantages. So what's the use of using that hybrid if it does have some disadvantage? Is it necessary to switch from the normally inverter and put in the hybrid? That's my question for you, sir.
Yeah. Then one question also generates another question, and that is, what do you have? What kind of setup you are usually working with? And when I maybe answer this, is that you have a normal setup with solar panels, a controller, and a battery, and then going from the battery from DC to AC in a separate inverter. Is that correct?
Yes, sir.
Yeah. And this is in a situation where you have no connection to the electricity grid. And this is, let's say, the setup as the basic setup, which is conventional technique, where every function has its own apparatus, its own machine, its own cabinet, and an hybrid inverter is actually putting all this together in one apparatus, in one cabinet, which saves cost and saves installation cost. And you see that the manufacturers are now also already moving into that direction. But in case, and that is often the case in South Africa, that you are not allowed to connect anything to the electricity grid, then the old situation, which has solar panels, controller, battery, and an off-grid inverter, is the basic setup. But when you have the possibility to interchange energy with the electricity grid, so with Eskom, and I understood from Akash that in a few cities now, this is now, let's say, as a sort of pilot, will be introduced or is being introduced. So I hope that soon in the whole country this will be a common setup. So when you have the situation of interchanging energy with the electricity grid, then making use of one machine, one thing that can prioritize automatically or can be programmed in such a way, then you have the most efficient way, and also in terms of investment, in terms of money, the most effective way of doing this. So that's the reason that we introduced this hybrid inverter also in this course, to make you aware that this is existing and how it is working.
Yeah, so Josh, just from a legislative perspective, there's every intention to sell back into the grid. However, we have a regulatory framework, where buying and selling is a local municipality competence. Even though the power gets generated nationally and produced and bought nationally, at a municipal level, they need to be competent or have the enabling tools to allow for selling and buying back. So not all municipalities have promulgated the regulation, are ready in a position. It's going to be a long journey, but it's a journey that the country is moving towards. There are one or two that have commenced that I mentioned, but it's definitely the path that the country is taking as part of its just transition, into alternative to the coal. I know it's a long journey because we've also got lots of coal resourcing in our country. So I hope that makes sense. That's why I thought it's important we talk about this, even though, for example, the colleagues are now, I Googled and I checked and I double checked and I asked ChatGPT. There's not a single municipality that I'm aware of in Northern Cape or Limpopo or Northwest, and I asked for Northwest Rustenburg, the biggest city, that this kind of mechanism or opportunity is currently available. So I just wanted to make you aware. But the colleagues, I think, know about that, and it's a way that we're going to go in time as a country. Colleagues, any other questions? I'm just going to put your hands up, please.
I have a question in the chat here. When mixing series and parallel solar panel, and what is the way of installing fuses? Well, what is the basic principle of a fuse? A fuse is to prevent a higher current than desirable through a cable. So when you have a cable, it can have a certain current before it gets dangerous. And when there is a possibility that the cable is getting too hot, so that you have a burning situation, or something else is burning because of a too high current, then you use a fuse. That is the basic theory. So when you have one string of solar panels, or one solar panel, or let's say a string of solar panels in series, there is a maximum current already coming from this string. So you don't need a fuse when you only have one string of solar panels going to the inverter. I talk about DC now. On the other side of the inverter, you are connected to a battery, and a battery can generate a high current. So in that line, you should place the appropriate or the right fuse. So counting up all the currents that can occur, and that is the size of the fuse within a certain limit. Then when the second, and that is the question what you are asking, when you have more strings of series connected panels in parallel, So when you make a larger system, then it is wise to make a fuse in the connection box, or when you have an inverter with separate inputs is already fused inside of the inverter. But when you have a separate string connection box in the field, then this box, there are fuses inside on the DC side. But on the AC side of the inverter, you should always look to the fuse that is there in this situation. Does that clear anything?
Cool. So let's just ask the colleague, Malatele, are you clear? Are you okay with that?
Thanks, Akash. Yeah, maybe just one follow-up.
Yeah,
to
go ahead.
clear. In terms of the physical location, where will those fuses be? Are they going to be on the roof or inside the building next to the inverter?
In this case, when you are coming down with different strings of panels, put them next to the inverter when you have more strings. But then you have a standard, let's say, connection box. And sometimes with roofs, you can put it even on the roof. When you go with one thicker cable, plus and minus, you go down to the inverter. Then these fuses are inside this connection box. So you stay on the roof with multiple cables. You connect them inside the connection box via fuses on one DC bar, and then you go after, and this is all fused, small fuses in every line, and then you go down with a thicker cable to the inverter. That is the normal, let's say, setup when you combine several strings. But the present inverters that are on the market normally say we are a string inverter, so you can input every single string on the inverter. So you don't need on the DC side special fuses.
Okay, thank you so much.
Yeah, when is this enough? So maybe we can discuss further also offline on this special case when you have a specific project where you want to make a design. But this is the case. Always think about the size of the cable, and can there be a much larger current flowing through the cable? Then you need a fuse.
Okay, fantastic. Colleagues, any other questions? So I think so. Malatele, the office open. You can take this offline. If you on your next project you want to design, Jos has made himself available to assist. Andrew, go for it. Just unmute yourself, Andrew.
Afternoon, guys. I want to ask, is it necessary to connect?
Can you talk a little bit louder or in your mic?
Andrew, we can't hear you. It's very low.
Let me take this off.
Yeah. That might be better.
Hear me now. Did you hear me now? Sorry?
Yeah, 100% better.
Okay. Is it necessary to connect the inverter using 4mm wire? And then again, if the inverter, maybe the fan is running non-stop, I can boost to put it another fan for extra for inverter to cool down.
When you use an inverter, let's say of 10 kilowatt or less in a situation of a family house, then 4mm square cables on the DC side is in order. Is that your question?
Yes, sir. Yes, sir.
Does that answer? Okay. Also, when the inverter is placed close to the in the house, close to the point of further or distribution board, close to the distribution board, then also 4mm square is also okay on the AC side. When you have higher power and much larger distances than let's say 10 meter or something, then it is desirable to go to 6mm square or even higher when you have higher powers. But if for a normal household, 4 millimeter square is fine.
Cool. The second question?
Go ahead.
No, it was around the fan. Go for it, Andrew. Andrew, ask it again.
Oh, so, yeah, I was saying if the inverter is running non-stop, sometimes because of the temperature, I can boost the inverter with another fan, extra fan, or it's gonna be fine.
So what he's saying is, if the inverter is continuously running,
Is running fan continuously with non-stop.
yeah.
So I thought maybe that is because of the temperature, maybe where we put it or something like that. I can boost the inverter with another fan to buy another fan and then just put it next to the inverter.
Yeah. It's always good to place the inverter in a ventilated room. There should be some kind of an airflow. When you have a very close cabinet, you are heating up the cabinet, and then the lifetime of the inverter can go down considerably. So it's always advisable to have a minimum airflow at the place where the inverter is located. And you can always monitor that when you see that the inverter at maximum power is heated up very much, then the inverter normally has an internal switch off when the temperature is getting too high. So when that is happening every day, or when that is happening much a large moment in time, then it is also advisable to make extra cooling. And even I saw examples that people, but then we talk about a larger system, that they put an AC, an air conditioner in the inverter room. But it is better to have some airflow in the room and to cool it on that way.
Okay, fantastic. Colleagues, any other questions? So we're just going to go to any other questions. You're more than welcome to ask the questions on the chat. I see a hand up. We're going to get on to you just now, Malatele. And if not, you're willing to put your hands up like the colleagues are doing in the class. The whole idea is just to learn, ask different questions, engage, listen to why they are talking about this configuration, why 4 millimeters instead of 6 millimeters, into that kind of conversation. Go for it, Malatele.
Thanks, Akash. My question is around lithium-ion batteries. When you connect them in parallel, let's say you've got an inverter, and then you've got 2 lithium-ion batteries. So definitely you're going to connect them in parallel, and then together they go onto the inverter. What is the difference in terms of the inverter when it's connected only 1 battery and 2 batteries? I don't know.
The batteries, when you want to increase the batteries, to have a larger storage capacity, then you can put these batteries in parallel with the same inverter setup and the same amount of solar panels. So then you keep the same voltage and you put batteries in parallel. But I also would like to shift this issue to the next course when we talk about batteries, and then we talk about parallel and series connecting of batteries and what is the best way to do. So maybe we can park this question for now.
Okay, so the next lesson is on batteries,
Okay,
right, Joss?
Yeah, the next week is we talk about batteries. Yeah.
Okay, we're going to a little bit deep dive. We've got an extra handout into that concept. Colleague, fantastic. Andrew, do you have another question, or is that an old hand, Andrew? I'm assuming that's an old hand, right?
No, it's an old hand.
Cool, fantastic. How many PV panels will one need for 5.12 kVA? It's on the chat. How many PV panels will one need for a 5.1?
Yeah, that is. I would like to show, to answer this question, I would like to show this picture.
Sure.
One moment. This one.
Cool.
Can you see
Excellent.
this?
Yeah.
Can you see this nice picture with different colors?
Yes.
And this gives an overview of what can happen and what is happening in a system where you have a battery and when you have the availability of a grid and when you have the system connected to a house or a building or whatever. So let's start at 5 o'clock or 6 o'clock in the morning when the sun is going up and the sun is on this example is on a clear day without any clouds. So you go here in this is the supply from the solar panels under this curve. And you see the blue area is direct consumption, or let's say this line is the direct consumption in the house. You see here lunchtime when you cook, and then it's going down, and in the evening you have some lights, and in the night you have less energy. So the blue thing is coming direct from the solar panels, because you see the solar panels are covering this, and even at already early in the morning, the energy from the solar panels is superseding what you are using directly in the house. So with this amount of energy, this green area, you charge your battery. And at a certain moment in time in the afternoon, the battery is full and you still have some energy left, because this orange part is the energy coming from the solar panels, but you are not consuming it directly. So what you do with it, and your battery is full, so what you're doing it, you're feeding it into the grid, you sell it, and then it's getting evening, the sun is setting, and in some areas this is already at 6 o'clock and then sharp. But anyhow, in the evening you use energy, and where is this energy coming from? Out of your battery. When the battery is empty during the night, you take a little bit from the grid. And even when your battery is larger, this can be reduced. And you are able to charge your battery during the day. So you can even optimize this. But of course, not every day is the same sunshine. And so you can have days that you have less energy available to charge your battery, then you need a grid more. And there can be days that you are feeding into the grid. So this is an example of how the energy flows can go in a hybrid system where you have a battery and where you have the grid, and where you can optimize your energy flows from the solar panels that you have. So, and now answering the direct question, how many PV panels will one need for 5.12 kilowatt hours? This 5.12 is basically the capacity of a battery, of a commercially available battery. And the straight answer is that depends on the energy uses in the house. And but what you normally see is that the amount of panels are also about 5 kilowatt peak, that you are able to charge your battery in 1 or 2 hours when there is no load. So with 5 kilowatts, so with 10 panels, this could be an optimal situation when you have 1-to-1. Sometimes it can be even lower panels when there is no load in the building. Then you're going to go down with your panels. But making this, let's say, design of how many panels to how many battery. Often in a house situation, it is used 1-to-1. But I would like to give me a few feedbacks from people in the field. What are you installing normally? Are you installing with this 5 kilowatt hour batteries also 10 panels of 500 watt peak or 400, that you have 4 kilowatt peak or 5 kilowatt peak, or are you installing much less or much more? I would like to have some feedback from the field in how the market is developing in in South Africa in these cases? Who can give me some? Who can share the answer on this question? Who can give an answer to this?
Well, fantastic. Will you just drop the slide for a minute, Jos? So
yeah,
we can see.
sorry.
Yeah, no problem. Who has an answer? You're more than welcome to answer it. Malatela, do you have the answer? Or are you?
Yes, Akash, I want to attempt to answer the question. I think
Fantastic.
the answer is lying on the type of inverter you are using. Because remember, the panels are actually reporting to the inverter. So the amount of panels will be determined by the type of inverter you are using. I think that is in a simplest matter. I can answer the question.
That's a very good point you are making, and that means that when you design a system, all components in the system should be let's say fit for each other, and that means you cannot put 100 panels on a very small inverters. And when you have a very big inverter and you install only 1 or 2 panels, you have not, from a money investment point of view, from your cost point of view, you have not an optimized system. So it should always be within a certain size. So it's very much correct to that the inverter is also playing a role. But let's say when you have this battery, how many panels you would advise, taking in mind that you have the right inverter? Can you answer that question?
Yeah, I would say 6 or 8 panels. That should be sufficient.
So that means in this case 3 kilowatt. That you are able to charge without load with, that you can charge your battery in a few hours. That is also a general, let's say, statement that when you have no load, but you have always a little bit of load in the house, but that you have that you can charge your battery with half the current of its total capacity. So that you need at least 2 hours to charge the battery in a full state, because you don't want to charge the battery with a too high current, and in order to increase the lifetime. But this is I agree with this. So that can be 6, 8, or even 10 the panels, depending on the size of the panel. The common size is 400 watt peak in South Africa at the moment, or even less.
Okay, fantastic. Okay, we have one more hand up. Sorry, there was one more hand up. Did I miss that?
Was me, Akash.
I'm so sorry, Enrico. It went down again. I couldn't see it. Go for it.
Yeah. Just a quick one. Good day, everyone. I don't know if it will be a stupid one, this one, but let me ask it. For an example, if you have a 5 kilowatt inverter. So normally then you will go, your panels must be slightly bigger than 5 kilowatt. For an example,
Yes.
you are still using during the day, you are using some of the electric which is being generated from the solar panels, and you are charging your batteries. So for an example, if you have say 4 batteries which you need to charge, or 2 batteries which you need to charge, which take up to 4 hours, 5 hours, and you already use some of the power. So wouldn't it be better if you have more than 5 kilowatt of inverter of your solar panel, because your inverter is already 5 kilowatt?
Yeah, this 5 kilowatt inverter is also commonly a standard size available in the market. And then again, we go back to the answer that is given before, how many solar panels you need for that. And this is a matter of sizing. And when you size the solar panels a little bit more than your inverter, is correct to do it like that. And then the question is the size of your battery. When you have quite some energy uses in the night, so you want to cover that with your battery, then you basically need a larger battery than when you say, okay, I want to have in the evening a few lights, and a television set, and then it's okay. I don't need anything anymore. Then you can work with a smaller battery, and that is all a matter of system sizing. And system sizing starts with the question, my dear customer, what is your expectation of your energy usage? So what is the load? What are you using? And what is wise to generate with the solar system and inverters and battery? So
the
it starts
principle,
always with this question.
but the principle is that if you have slightly more than the size of panels, it's still okay or generally accepted, slightly more to charge more to take care of existing items that's charging it, right? Did I understand it correctly? I'm an accountant, Jos. Please forgive me if I ask us. If Enrico asks you a stupid question, then he's at fault. But I'm an accountant. I'm not a technical person. So I can ask.
You are an accountant. You always want to have the optimum for your money, yeah? So you always want to have more. When you are a buying customer, you want to have more battery for the same amount of money.
Yeah, so there's different variables. So I'm assuming if you put more panels, it costs a lot more money, into the system.
Exactly.
But it brings down the charging time, and it gives it a little bit more capability.
Yeah. So
Okay.
in the lesson of that is in 2 weeks' time, in the lesson of system sizing, we will definitely come back to this discussion.
Okay.
And I know that this is important for you as a company. To make the optimum size, but also then one of the main advices is also look at your colleague companies or your competitors. Look at what are the wholesalers advising there, because most of the equipment available in the market is already optimized for a certain size. So it's already advisable that you have this size of battery and this size of inverter. They are already standard available, and this is because it has been developed over time to have an optimum system with this size.
Okay, cool, excellent. Colleagues, any other questions around this particular topic? So colleagues, while we're waiting, so I just need to make you aware. So just since we have everyone still in the class 63, so there's a couple of housekeeping. One is that in the next week or two, we're going to get, or in the next week, we hopefully get your agreements that I need you to sign just as evidence that you're attending this particular program. Then in about 2 to 3 weeks, I think you know that at the end of this course, we're having practicals. We're going to go into the community and we're going to install a small system. I think, Enrico, it's going to be 6 to 8 panels. Kind of system. It's going to be very, very small into it. But colleagues, we are going to ask, we're going to try to get a local installer. I'm hoping we give that opportunity to this class attendees, when we get to that stage. So in a few weeks' time, we're going to come back. We've got about 6 to 8 across the country or in the different precincts that we're going to install. So we will make a little call. We can't get everyone to do it. We're going to ask the class. We're not going outside, and hopefully we get one of you all to do that actual installation guided by a PUM representative. We're trying to keep it as circular as possible into it as well. So just watch for that. In about 3 weeks' time, we'll make a call to those that are attending the lessons to see if you could propose to participate and do an installation. Or we'll obviously pay you for it as well. But it's a small fee, it's a small little system. But we'll use that installation, assembly, sizing as the practical case study for the different regions. We're doing an actual case study into it as well. So wait for the agreements, which will come through in the next week. And then in about 3 weeks' time, we're going to make a call for proposals from this class only. For the different 6 to 8 installations, small installations. It's going to be at a clinic or an ECD center. We're going to leave it back behind as a legacy of this, but we need a few installers to help us with that, and we'll reach out to you, and we'll obviously get to know you, and you'll get your own PUM solar coach remotely to help you do that, and we'll even fly the coach down to do the practical training with you as well. So that's how we're going to get into the practical mode a little later on. So let's take any more questions on this particular topic. And remember, colleagues, you can still ask questions. You can still ask questions as you go. You can still ask for individual. If you're designing a complicated new system and you want assistance for this particular thing, you could ask for your own PUM coach to look at that user requirements, to look at the demand specification on that system, what it is, how it's been crafted, is it efficiently designed, and is it connected in the right manner, is the inverter inside or outside, is it a commercial or residential, are there any risks? So you could also ask for your individual coaching. And I told you we've already had one company in this cohort apply for. We've had 3 companies wanted to meet, 2 didn't really qualify for it, and the 1 we've already applied for it as such. Colleagues, I'm going to take one last. We have 10 more minutes or so left. I like the conversation. I want to say maybe if you put your hands up, if you have any questions or any clarifications for this particular topic, you can still ask going forward. At the end of today, Miranda will post the actual recording. Justice, I'm going to get to you in a minute. And then maybe a little later this week, Wednesday, Thursday, I will post the next video, which is around the batteries. We go a little bit more deeper onto batteries, the different types of batteries. Yes, I need to also make you aware, battery performance and temperature. In many of these precincts like Northern Cape, where some of our colleagues, and Limpopo, the temperature gets anything up to 40 degrees and 45 degrees, sometimes 50 degrees. And I'm told lithium ion is not always the best on those temperatures, but I'll leave it for you to cover those local nuances next week. Cool. Justice, go for it.
Okay.
Yeah.
No, I just want to, I would like to check. Afternoon, everyone. I would like to check if, let's say, for instance, I would like to know who's the coach that I can speak to directly, maybe without posting the things on the group. Is there a specific coach for Northern Cape Postmaspec side?
Oh, absolutely. So Justice, drop me an email, right? We'll look at your need. We understand your need. We've got in the solar coaches, we've got like maybe 30 on different specialisms. So if you drop us a note, I'll maybe meet with you with yours quickly, for virtually for half an hour, understand your need, and then see how we can help you. So there's no one. I'm the man in the middle. I'm the circus master, or I'm the class monitor. So drop me an email. Tell me what you're looking at. I'll set up a meeting. We'll quickly engage. I'll even invite Jos and Martin if they're available. We can have a conversation, and then we'll say, understand your need, and then they'll look for us within the broader pool of PUM experts, who is the best coach to help you if they can help you. Does it make sense? So drop me an email. Tell me what your need is to Akash only, not the whole class, and then I'll set up our 30-minute huddle with you and to understand your need.
Okay, loud and clear.
Fantastic. Okay, cool. Colleagues, any other questions, any other clarifications? You also, as you're going this journey, if you have any other questions, you're welcome to ask. So, but Miranda will post the YouTube. So I'll encourage you to share this, colleagues. So what you saw, the recording for today, the handout, even though we only allowed one person per company to come, you're welcome to share this with your staff. Give it to them to learn. Give the handout to them to learn, because at PUM and Anglo Zimele, they want as many people to benefit. We could only have X amount in this class. When we do the practical training, we could have X account, but it doesn't mean what you learn, you can't share it. You're welcome to share the handbook. You're welcome to share the slides. You're welcome to share the pre-video. You're also welcome to share today's class video, with colleagues or youngsters that you want to train. Okay, cool. Andrew, go for it.
Yes, I just want to ask something, but this is different. There is other panel, they call it mono panel. So what's the difference between mono panel and the one that you are using now?
Okay. I think monocrystalline, is that what you're talking about?
Yes, sir.
Yeah, last week you quickly covered the mono and the other poly, I think it was yours.
Yeah. Well, basically, you have different kinds of technology available in the market from the past, and And I think polycrystalline is still being used in South Africa. Basically, polycrystalline is more blue and monocrystalline is more black. That is the basic difference. And monocrystalline is normally a little bit more efficient than the poly. It's also a little bit more expensive. And so what you see nowadays is that you have the completely full black solar panels, which are always monocrystalline. Some have even a new technology which is called all black contact. They are really completely black. You don't see any silver lines anymore. So basically, the polycrystalline, the blue ones, are somewhat older technology, which are also cheaper, a little bit less efficient, and mono is a little bit more efficient, a little bit more expensive, and that is the way. So it is more or less the same in terms of financial performance, but when you really want to optimize, then I encourage you to look at the latest products that are available. But everything is depending, of course, what kind of customer you have, and maybe you want to optimize it towards the budget, and you can make use of some very cheap solar panels, which is still possible. But always take in mind that when you have to give a longer guarantee, that you also act professional towards this point of the business.
Okay, fantastic. Cool. Excellent. Colleagues, any other questions, any other clarifications? We've still got a few minutes left. We've done well for time today, Jos. Thank you. Well done.
Okay.
Any other questions? Any other clarifications? I just want to quickly see the WhatsApp chat. So in summary, colleagues, I don't see any other chats. Miranda, is there any other questions that you see on the chat?
No, Akash.
No,
Okay, fantastic.
not yet.
So, colleagues, we're all good to go. You still have the content. You still have access to Jos and to us if you have an individual, like kind of question, as Justin was saying, you want to have a one-on-one. Absolutely, no problem. You can even have your own one-on-one coach for your own company. That's also a possibility. We have a limited few places. You could get your own dedicated coach or expert advisor based on your need, design of products, maybe some training of staff, and we will arrange it. It's all available and that's the idea. We talk about a topic, it ignites interest, and hopefully PUM can assist. But that topic is a virtual and some practical conversations. I will send you the agreements in the next week. Miranda will post the video for today on the chat, and maybe by Wednesday, Thursday, I'll send you the reading material for the next topic on batteries, and then we'll be good to go. And then I think, Miranda, our next session is next week, Monday again, right? No.
No, Akash, and the next is on the 9th.
Okay, fantastic. See, lucky I didn't say
this week.
Yeah, the next one is on a Wednesday.
Okay.
On Wednesday, the 9th, batteries, yes.
Okay, excellent. Cool. Okay, so colleagues, we're not having next week the class. It's not on the 7th. It's actually happening on the 9th. Into it as well. But you're more than welcome to ask questions. Justice, you want to ask again? Go for it.
No, I just want to ask on the 9th, roughly what time? Is it every time 2 o'clock?
Yeah.
2 o'clock.
Yes.
Well, so Miranda, maybe you can send the diary block or send the actual meeting notice so it goes in everyone's diary. They're all aware of it and start reserving time.
Okay.
Cool, fantastic.
Right.
Colleagues, thank you so much. Jos, thank you. Deeply grateful for volunteering your time to have this conversation, to train, engage, and stimulate interest amongst everybody. So we will start getting the conversation going. You're welcome to ask questions. Think of this as your continuous professional development time, but use it to train everyone in your company. Colleagues, thank you so much. If you need anything, just shout in the WhatsApp group. And then, Justice, I'll wait for your email to have a one-on-one kind of conversation. Ivan, you got a question? Do you have I'm so sorry. Ivan, do you have a question? Ivan, did you put your hand up?
No, Akash, I just say greetings. That's
okay.
all. Thank you for the wonderful module, Josh, Miranda, and all the guys that participated. We see next week again each other.
Okay,
You're
fantastic.
welcome. Have a nice
Okay.
week.
Thank you.
So, goodbye.
Okay,
Yes,
bye.
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 Bye. Bye.
Bye.